Okay, what happens when an administrator hide their server detail and you need to figure out exactly what operating system they are running? Well, in this video, we are taking our Nmap skill to the next level with advanced banner grabbing and operating system detection. First of all, I'm gonna show you how to pull the server banner to reveal exactly what software version are running and how Defender can actually spoof them to track you. Next, I'll be talking about how to identify a target's operating system using the hyphen O flag. Okay, and lastly, I'll cover the operating system guess feature and the aggressive scan flag, so you can force the Nmap to give its best estimate when a target is hiding. And now, without any further delay, let's get started. So first of all, let's talk about what is banner. It is a welcome message when you connect to some server, and in response you get that message, and that message is basically what we call the banner, and it's the first thing you receive from the server, right? So let's take the example of SSH. For example, you connect to the SSH and the first thing you will receive is this banner of the server, right? So it's like saying that, yeah, hey, I'm running this specific open SSH version, and here you take it. You did not ask for that, it just told you itself, right? Now you might have a question, why do we even have the banner, right? So let's talk about that. Here you can see, here are the few reasons the server actually send the banner to us when somebody connects to us. For example, it helps the administrator know which software is running and what version, and it also helps the program to know that they are actually talking to the correct or right server, and also helps in the troubleshooting, right? So when this is why these are the real legitimate reason the server send the banners to when somebody connects to it. But if we zoom out and look at the banners, they can also be abused by the attacker. It can be also used in a bad way. What I mean by that is, as I said, when you connect to some server, it sends you, most of them it send you, it's like that, whatever it is running and with what version, right? For example, with this analogy, imagine you have your imagine that there is a house, right? Two house, not a single house. The first house has no signal, like no sign, nothing, anything, you cannot tell anything uh about it, while the second house has some signs that saying that it is using some specific model ABC 1.1, whatever that is. I mean, let's just assume it is a log system, okay, and they've somehow figure out that there is a version written on that log system, whatever or however the log system, it doesn't matter, but just understand what I'm trying to say. Okay, so now the bad guy just figure out that this specific log system is installed on that home too, while on in home one there is no any sign on their log, right? So what do you think, which house looks most interesting? Do you think house one or house two? Because the house two has a sign and it has also a version of that specific log, and that log might be a very old or might be newer. We don't know, but we just look at the version and we then research and look for that if any somehow we can break that log system based on its version. If it is an older version, most probably it might have some ways, some methods to block that log in order to get into home, right? So that is exactly the same way why banners can be used in a bad way. Attackers usually finds out the service and its specific version, and when they get that specific version, they then look for the exploit for those services along with that specific version. And so as I said, if it is some older version service, it might have some vulnerability, and they can then use that vulnerability to exploit that service, right? So that is exactly why the banner can be used in a bad way. Another most important thing is sometimes you will see that the server, the full information about the version, everything, you will be able to see that, but in some cases you might not be able to see the full information because that the administrator might remove that information on purpose so that nobody can see that. That is second case, and another case is that you might see something like this when you do the scanning and try to finding out the service and its version. You will see something like this. For example, port 80 is open, it has HTTP running, and it is running Apache, but we don't know what Apache version. So the question mark over here, you see that it means that the Nmap did not get some enough information that it let us It means that Nmap didn't get enough information to tell us specifically which specific version of this Apache server is. So instead, it just added the question mark. Now here's where we can use the service detection intensity to Nmap will be able to try it more harder to figure out to find out for pattern or small differences, and it might then give us a bit more better result than the question mark. Remember I explained about the service detection intensity in the last video. If you watched that, you probably understand this, but if you have not watched that, I probably recommend checking out first, right? Now I think we are done with the banner. What is banner and why banner grabbing, what banner grabbing means and how it help us actually, right? Now I think we will talk about now the operating system detection and the fingerprint. Okay, so first of all, you see over here this hyphen or when you are doing this type of scan, when you are trying to find out about the operating system detection, you have to use the hyphen or when you are doing the nmap scan. Okay, and now let me explain what the operating system detection mean. Okay, so it means it is like I mean, you can understand it from the name itself that operating system detection is like you trying to figure out which operating system is the machine running. Is it a Linux or is it Windows or is it a Ubuntu or some other operating system, right? So that is what the operating system broadly is. Another point here is that a different operating system behave differently on the network. For example, look at this example. Okay, so imagine we have two-person. We have two-person. Okay, person A writes hello and the exclamation mark, and the second person write hello and this guy right here. So it is the same message, but the if you look at the pattern, it's the same. It's a bit different. Similarly, different operating system, as I said, behave differently. So and that difference is what make the nmap enable to figure out those differences, those small differences, and based on that it tells us that which specific operating system is the machine running, right? And just like human have fingerprints, all of the humans have different fingerprint. Same over here, if we apply the same concept over here to this operating system detection, all of the operating system kind of have different fingerprint, and based on that fingerprint the nmap is able to find out to distinguish between that, yeah, this machine is running the windows or it is running the linux, right? Let's talk about shortly or quickly how nmap is able to do this, like how it figures out. So when we run our scan with the nmap hyphen o and target rp, it basically send the some packets to the target machine, and whatever the target responses back, replay backs with packet, those packet uh, whatever the target replies back with some packet, nmap actually analyzes those packets, and nmap has all very Nmap then checks it with on database where all of the fingerprint are there for most of the operating system, and it then checks the packets that it received from the target and it compares it with its own database, and then it checks that it looks this pack. Okay, I received this packet and it kind of look like this pattern in my database, so it's probably Linux or it's Windows. So it then based on that it then reports to you that yeah, this is the operating system the machine is running on, right? And here are some of the thing nmap actually look at in the packets that I have told you, that it checks analyzes the packet. One is the ttl value, okay, another is the tcp window size, another is the tcp option. So different operating system kind of behaves differently in the TCP packets. It kind of includes the packets in different ways or might add some extent for information based on the operating system. This is this part, okay, that I have told you. I'm just gonna quickly explain it to you. Another thing is that the TTL value, okay, time to live value. This is this is for Windows it start from 64, and for Linux it start from the 128. So if you look for the TTL value around it and map look at the TTL value around 60 or a bit lower or a bit higher than that, but around. So Nmap actually look at the TTL value and kind of based on that tell you that yeah, this might be the operating system, either window or Linux. Another thing over here that it looks for, that it is the TCP window size. What is window TCP size? I have actually, I guess, talked about in the previous video, but let me quickly tell you. When you like, for example, this is your machine and this is some website or some other system, and you want to connect to this guy right here, to this website, to this server. Now when while connecting to this, you actually agrees that I actually my TCP window size, that I can actually receive this much information at once. So this guy tells that this guy that I can receive this much information at once, so you will have to send me this much information. Like as you like, let's take simple example. This guy said that I can receive 5 line of information at once. So when the connection getting established, it tells this guy that I can only this guy understand that this person A only can receive the 5 line on information. So they agree, and then they start communicating. This guy just send 5 line information to this guy, it processes then 5 line. So what I mean by that is, as I said over here, 5 line, this is specific window size of the TCP, okay, when sending information. So different operating system might be, some might send a bit more or some might less based on the operating system. So Nmap also checks it with its own database, these TCP window sizes. So hope you get the idea. And sometimes Nmap cannot tell you that what operating system it is for whatever reason, like firewall or some other reason, but it doesn't tell you, right? I mean, not because the operating systems can fail or the Nmap fail, but it did not get enough information. So what we do next is we have another thing over here, okay? The operating system guess, okay? So when you add that, actually normally it will be like, I don't know what the operating system it is, but if you add this guy right here, it's like you are saying that give me your best guess anyway based on what your information you get. So based on that info, so based on this, the Nmap will then tell you that yeah, it might be this, or it might be this, or it might be this. So these are the guesses it then makes, right? So hope you get the idea how all these things work. Now look at this one. This is how we can actually do the operating system detection scan. So this is the Nmap, this is the O for operating system detection, and this is the target machine. So over here I'm on my kernel Linux, and what we're gonna do is I will just do the Nmap -o and then specify the target, okay? So this is the target machine IP, and let's just start this scan and wait for the detail. So look at this report we got from the Nmap. These are the ports, and this is the TCP IP fingerprint. This is actually what the Nmap compares with its own database, and based on that tells us that what operating system this is. But I guess it is fair, it gets fair to tell us what operating system this is, but you can try this. Now what we can do is let's use the operating system guess part, okay, that part, and it will then try to help us. So to do that, I'm gonna just write osscan-guess, and it will be like this, and let's just start this and see what we get now. Okay, for some reason the machine is not opening, but actually I run both of the scan. The first one did not tell us anything, but we then check the operating system guess apart with it, and this is the scan, that this is the result, this is the report that the Nmap gave us. So this is exactly the same as previous one, but this part over here, if you look at this is new, okay? And it based on the it's confident that this might be the operating system, this might be the kernel version of the Linux specifically, or this might be the version. So based on that, it just tell us that yeah, the first one we have is the Nmap is basically saying maybe it's Linux 3.1 version, or it's because it's 95% it is confident, and then the second one it is saying maybe it's 3.2, and then we have a lot more different versions. So this is when this is what it gave us when it is not giving us exact detail, exact version. So we then use this guess, and based on that we might assume that it might be, but sometimes it is not real. Sometimes it may be wrong, it may be incorrect, right? So this is all about the operating system detection. Hope you get the idea how this works. The last thing we're gonna do is actually it's the this aggressive scan, and we actually do specify it with the -a. Okay, so simply what it does is, remember we talked about the -sv in the previous video. It finds out the service and version detection, and then in this video we talk about the -o operating system fingerprinting, finding out information about operating system and its version. And the -s is the default NSE script. It just do these. I'm gonna explain this in a later video, but think about it just kind of run some kind of script, okay? And we also talk about the trace route in the previous video. It maps out the hops and whatever network it goes to the packet to reach the target. So when you do the aggressive scan you it just you are kind of saying to the nmap that I want to do all of these scan at once, though you can specify all of these flag in the same command separately, like first you type the sv, then o, then sc. But there is one, we have the aggressive scan. You just type the -a and it just do all of this scan one by one, and it gives you a lot more very comprehensive detailed result. And based on that you can look at the information and do the stuff and plan the next step, right? So this is how all of these things work. Hope you get the idea. If you have any question in any of this, let me know. And in the next video I will talk about the NSC script. I will explain what it is and a lot more of the stuff about it. So for now I'm just gonna end this here. See you soon in that video.